Welcome to Citizen Science, stories of science we can do together, coming to you from SciStarter's sweltering world headquarters. In this episode, we're taking a refreshing dip into an ocean of marine citizen science activities that includes swimming with sharks, chatting with manatees, and sleuthing out sea dragons. It's summer here in the Northern Hemisphere, and it's especially oppressive this year. So let's escape for a little while, shall we? Down to the seashore, where a refreshing ocean breeze is blowing, and splash into the frothy waves and then dive under, hovering weightless over a shimmering coral reef, joined by colorful butterfly fish, a friendly grouper, and... what's that? Shark! Wow, those sound effects are terrifying, but sharks shouldn't be. Yes, sharks are large, fast-moving, sometimes lethal things with which we share this planet, but so are cars, and they are by far more lethal, killing 40,000 people per year in the U.S. alone, but we don't run in terror every time we see a car, right? They are to be respected, but not feared. Sort of like sharks, and that's the attitude our first guest hopes to share. Marine scientist and shark enthusiast David Schiffman is author of the book Why Sharks Matter, a deep dive with the world's most misunderstood predator. We dragooned David into speaking with us in between his visit to South Padre Island in Texas for a sea turtle release event and just before his West Coast shark book tour, partly so that we could use the word dragooned in this podcast, but mostly to get his take on the current state of affairs in shark research, conservation, and citizen science. Hey, David, thanks so much for being with us.
Thanks for having me, Bob.
Yeah, especially now, we're so close to Shark Week. You must be going crazy.
It's a very busy time for my people.
So our theme is under the sea, but let's focus on sharks, of course. And so, for our listeners, what do you think is really cool and interesting about shark research, like right now? Or is there anything special, or is it just kind of a continuum?
There's weird and neat stuff happening all the time. Just this week, there was a study that apparently stingrays can make sounds, which we did not know until this week. So there's cool stuff happening all the time.
And this might be impossible to answer. And I guess the general way to ask it is, why are sharks so weird? But more specifically, it's like we have hammerhead sharks. We have, members of the shark family that have saw blade heads.
Yep.
And goblin sharks. We don't have saw blade frogs. We don't have hammerhead cows. Why sharks?
So sharks have been around for a really, really long time. There were sharks swimming in the ocean not only before there were dinosaurs on land, but before there were trees on land, before there were rings around Saturn. So this is a really ancient group of animals that has speciated to take up a huge variety of ecological niches. And if you think the ones that are around now are weird, you should see some of the ancient extinct ones. But they're really, some species like hammerheads are super well adapted to particular ecological roles. They use that hammer shape in a few different ways. One is all sharks, skates, rays, and chimeras have this electric sense that other animals don't have. They can sense electromagnetic fields. So that means if there's a prey animal hiding under the sand where you can't see it or hear it or smell it, they know it's there because they can sense the electricity given off by its beating heart.
Oh, wow.
And you'll see hammerheads sweeping across the seafloor like a person with a metal detector at the beach looking for buried treasure.
Oh, my gosh.
And all sharks have that, but the cephalofoil, the hammerhead of the hammerhead sharks, is extra surface area for that sense. They also use it to pin down flat prey like stingrays against the seafloor that they can munch on it when it can't get away.
Wow, very cool. So for our listeners who are interested in getting involved in science research, maybe actually getting their feet wet, I mean, not bitten off, just wet. What sort of shark research might they look to? Are there researchers who are looking for help?
There are some cases where members of the community can assist with marine biology research. There's something with NOAA, which is the U.S. federal government agency that does ocean science and management. They have what's called the Cooperative Angler Tagging Program. That's if you catch particular species of animals, you're given a particular tag. you put the tag on it, and then you mail in a little postcard that says, I used tag number 317. It was on this animal. Here's how big it was. Here's where it was. Here's the day I caught it. And then when it's caught again somewhere else, then the government is able to track that. And this is one of the oldest citizen science programs in the world. And it's got tens of thousands of tags deployed.
Wow, amazing. So you wouldn't happen to know of any sources of more amazing shark lore and information, perhaps in a brand new book that people might be able to acquire?
I have a new book out that is all about the science and law of shark conservation, designed for the general public, not a textbook. You don't need to be a PhD or a lawyer to read it, called Why Sharks Matter, a deep dive with the world's most misunderstood predator. It is thorough and systematic and explains step by step all the reasons why we know that sharks are awesome, all the reasons we know why they're important, all the ways that we know that they're in trouble, all the things we can do about that, and the evidence for what works and what doesn't and when, as well as what people can do to help and what people have been doing that does not especially help.
Huh. And are you out promoting that? Are there ways that people can come and see you and get an autographed copy, perhaps?
I am in the midst of a 40-city book tour, just about halfway done with that. As of this recording, I just got back from a week in South Texas, where I spoke at a zoo, an aquarium, a university, and a sea turtle conservation center. Huh. So I am traveling all over the United States and Canada and the UK and one stop in Spain. Folks can follow me on social media, Twitter, Facebook, and Instagram at Why Sharks Matter, where I'm always happy to answer any questions that anyone has about sharks. And also I post info on upcoming tour stops.
Well, thanks so much. Thanks for taking the time to be with us in this very busy time of year.
Thanks for having me. Happy Shark Week, everyone.
David mentioned that just recently, scientists discovered that stingrays make sounds. And before we continue, I can't resist playing you those sounds. They're the loud pops you hear, and they make them as a diver approaches. They become even more emphatic as the diver follows the fleeing stingray. Those recordings that made this article possible were made by a non-scientist, a diving instructor and cinematographer named Philip Christoph. The article is titled Evidence of Sound Production in Wild Stingrays. The lead author is Lachlan C. Fetterplace at the Institute of Coastal Research at the Swedish University of Agricultural Sciences, and it appears in the July 18th issue of the journal Ecology. The fact that this stingray behavior was only recently discovered highlights the fact that we still have much to learn about the ocean and its inhabitants. After all, oceans cover over 70% of the Earth's surface, and there are only a few thousand marine scientists. Our next guest has been working for about a decade on a computer platform and app that allows citizen scientists, including divers, people in the sport and commercial fishing industry, and even beachgoers, to contribute to marine science research. It's called eOcean, and Christine Ward-Page is its founder and director. All right. Hi, Christine. Thanks for being with us.
Hi. Thanks for having me.
So eOceans, this is a little different than a lot of the projects that we have, because so many of them are, they specialize in just, bumblebees or whale sharks or one species. And eOceans seems so comprehensive. So can you tell us a little bit about eOceans and your approach?
Well, I guess I could back up a little bit. So I was a marine scientist. I started what's called crowdsourcing, or previously, now it's called citizen science or participatory science. But I started back in 2004 and I was tracking sharks. So I had eShark. And then I ran an eManta project, which we wanted to know how manta rays were doing around the world and see if they could be listed on CITES. And crowdsource data on manta ray populations. And then we had the Global Shark Conservation Assessment Project. And so I was running all these different projects, and I thought, this really is terrible from a user's perspective. Mm-hmm. So all the people that were participating in all these different projects, they have to provide their different information and perspectives for all these different projects, as well as to sharks and seahorses and turtles, to all these other projects for other researchers. Uh-huh. And so about 5 years ago, I said, okay, enough. We have to have a one platform that works for scientists, participatory scientists, citizen science, crowdsourcing for all aspects of the oceans. And so eOceans is a platform. We have over 200,000 species, and you can track any part of the world's ocean or any issue like plastic pollution,
Wow.
oil spills, all in one place. And then the data are instantly analyzed with expert analysis at that spatial scale in real time.
Wow. So who uses the data that's collected, in all of these projects?
Yeah. So the way that eOceans works is that the user who's contributing the data,
Mhm.
it's their data. And so they can use it if you want to track your own fishing or your own records of how much activity you spend in the ocean, you can do that. But if you want to share that data with different whale researchers or turtle biologists or governments to track the blue economy or blue carbon, then you can do that. And so then whoever starts a project, so every project needs to start with a mission, a goals and objectives.
Mhm.
And then you as a user can join those projects and instantly share with you could share with one whale researcher or 400 whale researchers by
Mhm.
instantly joining their team and providing that data. And then the data has used, so myself and another quantitative ecologist, we do spatial analysis with the data to match the project's objectives. So if you want to track sharks through time and through space, or shark diversity, or their threats like climate change and pollution or habitat destruction and these sort of things, you can track it in real time. But everything is focused on the project's goals and objectives from the beginning of the project.
So you have the users, the people who are helping the scientists who are going and maybe just tracking their own data for their own use, but you also have people who start projects and invite others to contribute to it.
That's right.
So who are those folks?
Yeah, so it could be governments, it can be NGOs, it can be specific researchers. So, for example, if eOceans had existed when I was tracking sharks or rays or shark sanctuary policies in the past, I would have been able to start a project, have people join it, and instead of them, they can log their dives and be logging their sailing or using their captain's log, everything's happening. And now all of a sudden this project starts. Now I can instantly stream it to that project without having to reinvent the wheel. So yeah, NGOs, researchers, community groups, there's quite a lot of community groups that are concerned about their own invertebrates, whether it's barnacles, or on the West Coast, there's a lot of marine heat waves that have, taken out massive numbers of communities. So they're concerned about these things, or they're just interested. Fishers that I work with, they said they saw, massive schools of basking sharks off the coast of Nova Scotia, where I live, and no one was listening to them. And so they're like, there's just certain things that people are just interested in. So then they can create a project, and they have expert analyses analyzing their data and controlling for changes in effort and through time and through space and through, physical, chemical, like temperature and stuff like that.
Wow, it's so comprehensive. Are there projects that you want to highlight just to kind of bring it down to the more granular level, people understanding it?
Well, I would say the first one we put in was eShark. So eShark was, stemmed from my PhD in 2000 I finished in 2010. It's mostly focused on the dive community that are interested in tracking where sharks are, looking at the trends through time and through space. So, I want to go see hammerhead sharks. When's the best time and the best location to go see them, and to dive with whom, sort of. And then So yeah, eShark is that, and eManta are the two big ones that we put in because it's based on nearly a decade of research. So now it'll be automated instead of doing it all manually like we did in the past.
Great. So the people contributing data there are divers. Are there projects for people who maybe don't get their feet wet so much?
Yeah. So if you're going along the beach, so I think of the blue economy as a really key one, because the blue economy is how people use the ocean, really, and it's how people use the ocean that supports ocean life and biodiversity. And so if we can see, who's using the ocean for different purposes, like if there's a swell for surfers and a nice place for sailing and another place for beach walking, and then you're tracking the value through time, but you can also track if something happens like an oil spill, you can have more accountability around what the impacts of that were, or of climate change, or things like that. But it can also help with, creating ocean access in some places where, more and more people want to access the ocean. You can see where to add more accessibility, where governments could add more accessibility. So yeah, even if you're just going, and then, so on the note of people who are, just getting started in the ocean space and aren't ocean scientists or not yet ocean enthusiasts, there's a field guide inside of it that we're building. So if you don't know what species is, you say, oh, I saw a turtle, but I don't know what species. There's a field guide in there that can help you identify the species that we're starting to build out. So
just to get it straight, so Blue Economy is its own project, and then the field guide is a separate.
Yes.
And so for listeners who now are intrigued and want to get involved, do you have any advice of how they get started?
Yeah, I would say the first thing to do is to download the app. It's available on iOS and Android. And then you can follow me. And I'm reporting stuff in the app, and then learn about what I'm seeing in the ocean. And then once you feel comfortable, you can start logging your own observations.
That's great. All right. Anything else that we haven't gone over that you really want to make sure people know or understand?
Yeah, I would say the one thing is the ocean changes really fast. So every time you're in the ocean, if you look around, do you see a team of marine scientists studying everything that you see? Probably not. So that means your perspective and the observations that you make are a unique piece of the puzzle of what's happening in the ocean in that location, in that place right now. And so we stitch those pieces of the puzzle together to make a more complete map of the world's oceans. We want to do it for every minute. So we aim to gather 1 billion observations a day and to generate 1 million analytics per month so that we can track the social, biological, and anthropogenic aspects of the ocean in real time.
Wow. All right. Well, thanks so much. Thanks for being with us.
Thanks so much. Have a great day.
You too. Bye-bye. Tracking and monitoring sea creatures is enormously difficult. The ocean is vast and many species are in constant motion. Fortunately, new techniques using computer vision and artificial intelligence are now available, partly thanks to our next guest. Jason Holmberg is founder and director of Wild Me. All right. Hi, Jason. Thanks for being with us.
Thanks for the opportunity to talk about Wild Me.
Yeah, so could you tell us about Wild Me and how you got started?
So Wild Me is a 501c3 nonprofit organization here in the United States. It evolved originally out of ongoing whale shark research that I participated in. So back in 2002, I swam with my first whale shark off the coast of Djibouti as a scuba diver, fell in love with the species, ended up the fall of the same year going on a tagging trip for whale sharks, in which, this is old school tagging. It was a spear and a placard, like you might see on somebody's desk with their name on it. And they would attach that placard and a metal line to a little spear and stick that line and that tag under the skin of a whale shark. And so as I'm out with a researcher on this tagging trip, bobbing up and down in the ocean with this microlight buzzing overhead out in the hot sun in Mexico, I asked the whale shark researcher, so this tag you're going to stick on the whale shark, how often do you recite it? And he said, about less than 1% of the time. And I have an engineering background. So anytime you have a process that's 1% efficient, I guarantee you as an engineer, I can get you to 2, right? That process was so inefficient, and it, literally harmed the animal, maybe not a lot, but could potentially cause infection by breaking its skin. So I immediately started working on, can we operationalize this idea, which had been floating around already in the whale shark community, that whale sharks can be naturally identified by the spots on their skin, like a human fingerprint, unique to each animal.
Jason happened to discuss the problem with friends from NASA, one of whom worked on processing images from the Hubble Space Telescope.
Scientists needed a way to take multiple photographs of the night sky and stitch them together into a giant mosaic, a bigger picture, if you will. And what they needed to do was identify star patterns in common, fix those in place, and then allow the photographs to be at a common zoom and overlap in that manner. Matching star patterns, white spots on a black background, is pretty much exactly what we were trying to do on a whale shark if you just think about their spots as a natural, star pattern. So I began working with a colleague at NASA named Dr. Zavan Arzoumanian, Brad Norman in Australia, who is a foundational whale shark researcher. And we developed spot pattern recognition for whale sharks. More importantly, we put it up in the cloud where anyone could submit data, and any researcher without Python experience or Java code or anything could log in through their browser and run that spot pattern recognition algorithm in order to begin matching their whale sharks.
And as AI and pattern recognition advanced, Jason and his team moved beyond just whale sharks.
So then we developed Manta Matcher, and it used a different computer vision technique.
Oh, okay.
So on and on until we get to the point where we really thought of this as, well, we're not just whale sharks and we're not just mantas. We need to think of ourselves as something else, as the software engineers, because there's already great people in the field. There are already citizen scientists who are diving and going on safaris, and there's already academics working on, either advanced population models for animals or advanced machine learning and AI for computer vision. What was missing is people like myself and now my team of software engineers and machine learning experts at WildMe were the engineers between researchers in the field, citizen scientists, and academics. And we are the folks who are responsible for taking this advanced technology and the needs of researchers and creating these online open source data platforms.
Okay, and what sort of animals are suitable for this, for the AI and pattern recognition technology?
So we're really looking at species that at least individual researchers can tell apart. We can then take those catalogs of individuals, whether it's African wild dogs, hyenas, giraffe, or my favorite, leafy and weedy sea dragons in Australia, just beautiful creatures, where scuba divers go in and compete every month in the Sea Dragon Search project to see who can photograph the most sea dragons. If researchers can tell them apart, then there's a good chance that our computer vision algorithms, and especially the newer deep learning techniques, can be trained to tell them apart in different photographs, and therefore, speed and scale the conservation community with these computer vision tools, which, by the way, is one of the things that's really needed to effectively allow a researcher to work with citizen science. Citizen scientists can generate so much data that they can literally overwhelm a researcher with photographs. So these computer vision techniques help researchers keep up with the citizen scientists effectively.
Mm-hmm. And for people who don't know, what's a sea dragon?
They're a type of seahorse or pipefish. They are absolutely gorgeous and incredible photo ID challenges as well. And so we built the Sea Dragon Search Wild Book, which is the software platform that researchers at the University of California and Western Australian museums and elsewhere in Australia all collaborate around to collect diver photographs of these beautiful sea dragons, and then to individually identify them based on the patterning of their long snouts.
Wow. All right. Well, is there anything else that we should make sure that people know, or something I just neglected to ask?
I think often we think of citizen scientists too much as just data collectors. But my own journey is as one of a citizen scientist. I'm currently executive director of a wildlife nonprofit where we have machine learning experts on staff, and yet my background is in chemical engineering and Arab studies. Citizen scientists can bring professional experience and wisdom directly to research teams, directly to engineering teams, directly to academia and nonprofits. We need technical skills, accounting skills, data science skills, information management. There's an incredible number of skills that go into the modern nonprofit or the modern wildlife research effort. Citizen scientists, especially those who really want to spend more time than just collecting data, should think about, how can they play a larger role? And I can tell you from my own personal experience as now sort of an extreme citizen scientist where my whole career has gone in this direction, I've found nothing but, welcome and support from both the academic and the NGO spheres for my participation in helping with research and conservation of some of the most beautiful species on the planet. So I would absolutely encourage anyone who has an interest in participating in wildlife research to really figure out, is there something more that they can do? Can they bring their professional skills to the table?
Wow, that is great. That is inspiring. Okay, well, thank you so much for being with us.
Thanks for your interest in WildMe.
Whales are famous for their singing. Dolphins are incredibly chatty. Seals and sea lions bark and bellow. But what about manatees? Do they vocalize? And if so, are they talking about us? Well, marine scientist Natalia Lace explains that, to start with, they're very loud chewers. Yes, that's the sound of a manatee chomping away on some leafy greens. And they also make these surprisingly high-pitched chirps. Not a bird, not a squeaky toy. It's a 1,000-pound sea mammal. But what, if anything, do these chirps mean? Natalia runs the Manatee Chat Project to study manatee vocalizations, and she needs your help. Hi, Natalia. Thanks for being with us.
Hi, thank you for having me.
So this is so cool. It reminds me of like Dr. Dolittle, Talk to the Animals, Manatee Chat. But we're not actually chatting with the manatees, right? We're eavesdropping on them. Could you sort of describe what goes on in Manatee Chat?
Yes, sure, exactly. Well, manatee vocalizations have been historically understudied, and because it has been generally believed that manatees make very simple vocalizations, mainly contact calls between mother and the calves. So they are often seen as slow herbivores who just not very social, not very smart. So they might have very simple vocalizations as well. But this is far from the truth, actually. Manatees can be found in very diverse groups, and not just during the mating periods. They often travel together. They're often very curious. They approach sometimes people in the wild. They like to investigate things. So they just don't get much credit that they actually deserve. So in Manatee Chat, it's our project where we investigate form and function of manatee vocalizations. So we try to understand if there is some complexity present, or if these calls go beyond simple mother-calf contact calls. So the majority of data set we're using was recorded in Tampa Zoo at the Manatee Hospital, where manatees undergo rehabilitation. And right now, this is a phase 1 project, which is hosted on the Zooniverse platform, where basically citizen scientists are asked to identify various sounds present in audio files.
Okay.
And we are looking specifically at manatee calls and mastication. Mastication is a sound of chewing. They have very distinct sound. They make very distinct sounds when they eat. So you can actually identify it in files as well.
Oh, wow. So are the citizen scientists listening to the files, or are they looking at the sonogram or the sonic... The spectrogram, thank you.
Yes, they actually do both. We ask them to listen and also to look at the spectrogram so we can identify sounds of interest better.
Now, it's not possible they're communicating while they're chewing, is it? I mean, they could chew in communicative ways, perhaps.
Well, they might do it at the same time, but probably it's going to be really hard. And actually, we did a little tally of how many files we had with both chewing sounds and the calls, and it's very rare. Just 4% of the files had both sounds in them.
Oh, okay. So you did look into this. All right. So, right. So now it's at the early stages. What are your goals with this?
Well, this is just the first phase we have right now, phase 1, where we looking at the files and we are trying to identify what these files contain. But this is a long-term project. We would like to see if we can find that manatees have distinct individual calls. And we also try to attribute certain calls to certain behaviors. So ultimately, this data could be used to develop the passive acoustic identification system that could help alert boaters, for example, that manatees are in the area. Or the system could be set up at wintering sites where manatees aggregate during the winter in warm water. So we might identify manatees who keep coming to the same sites year after year, if we can actually find that they have very distinct individual calls.
Oh, I see. To identify it down to the individual animal. Okay. Now, is there a concern that the vocalizations in captivity would be different than the ones out in the wild?
Well, the environment is definitely different because it's a manatee hospital, but these are wild manatees. They are not captive born. They just
Oh, okay.
spent some time at the hospital because they had some injuries from the boats or they have cold stress. So they stay at the hospital for a couple of months and then they are released. So the only difference is really the environment, the feeding schedule. So yes, it's probably has some sort of effect, but these are not captive animals. These are wild animals.
Okay, so let's say some of the listeners are interested in getting involved. What are the steps? How do they join up and start contributing?
Well, it's really easy to join. People can sign up via SciStarter. We have a page there for Manatee Chat, or they can go through Zooniverse, or they go through our website. We actually recommend to create the account on Zooniverse. It's free, but you don't have to have an account to start classifying those sounds. It is also a good idea to have good headphones because sounds can be faint and files could be noisy. So it's better to have some good equipment so you can hear pretty good. We also have tutorial on Zooniverse, which explains the whole process. And we also created a practice and a quiz on our website that could help citizen scientists to make more accurate identifications because sounds are very diverse and sometimes people cannot even tell if it's a manatee call or just some noise. So it's better to do some training a little bit.
Great. Anything else you'd like to share about the project that I haven't asked you about that you think people should know?
It's actually a pretty cool project because people get to listen to the calls they do not typically hear very often. These are sort of rare calls and they're unusual. And many people have been telling us how surprised they are to hear manatee calls because they expected something at very low frequency, something like rumbling, because manatees are pretty big. But instead, manatees are chirping almost like birds at very high frequencies.
Oh, that's
So,
interesting.
people are very, very surprised to hear how manatees actually sound. And also, people are surprised to see how different these calls are and how large their repertoire are. Because when you hear all the sounds, it gets really, really interesting.
Wow. I mean, there may be a whole language in there. I mean, it may be much more complex than we would have guessed.
Yeah, it's hard to tell if there's language there, but it's definitely, from what we see, it definitely goes beyond just mother-calf contact calls. So
Great. All right. Well, thanks so much for sharing this with us. And it sounds fascinating. And I'm going to join up and start listening.
yeah, sure. Thank you.
All right. Thanks. Bye-bye.
Bye.
Well, that's it for this episode. You'll find links to all the projects discussed here in the episode description. And you'll find lots more undersea citizen science adventures at SciStarter.org. I'm Bob Hirschon. Thanks for listening. This podcast is brought to you each month by SciStarter, where you will find thousands of citizen science projects, events, and tools. It's all at SciStarter.org. That's SciStarter.org. SciStarter's founder is Darlene Cavalier. And thanks so much to you, the listener, and the citizen scientist for getting involved and making a difference. If you have ideas that you want to share with us and any things you want to hear in this podcast, get in touch with us at info@scistarter.org. Once again, our email address is info@scistarter.org. Thanks again, and I'll see you next time.